Okay, so class, let's see silicon. Silicon is somewhat more electropositive and larger than carbon. Electropositive means silicon can much more easily give away its electron. It is an electron donor and larger than carbon. This makes SI bond very unstable, so that there are no practical value in the formation of polymer. So SI bond is very unstable, therefore polymer cannot be formed from it. The SiH bond is quite unstable also and very reactive, and this is useful in preparing silicon derivatives and in delicate control of the cure of silicon polymers. So this is like silicon derivatives can be made by this bond, but it is still very difficult to control. The SiC bond in organosilanes is very stable, making silicon polymers useful in high temperature elastomers. The methyl group attached to silicon contains CH bond, CH3 methyl, which are quite stable but are still sufficiently active to permit some vulcanization by peroxides under vigorous conditions. The projecting methyl group also provides surface of low energy and surface tension and high lubricity, which are useful in surfactants and in release coatings on paper, mold surfaces and cooking utensils. So whenever these properties are there, cooking utensils can be made. Which two properties? Low energy, surface tension, low surface tension, low energy and high lubricity. Then SiOH, silanol bond, is very reactive and polymerizes rapidly to form silicones. Silicones are SiC bond. The SiOR, organosiloxane bond, is often quite reactive and polymerizes or react with substrate fairly readily. The SiO-Si bond in both glass and silicon polymer is very stable to heat. It is liable to acid and alkali, labile to acids and alkali. Easily broken down, so it can be easily broken down by acids and alkali, and this reaction is useful in the preparation of silicone polymers by equilibrium. Okay, all of these reactions are used in the polymerization, casting, vulcanization, cure of silicone elastomers, resin and coatings. So if you read it, pay attention to every word, you will understand. Now phosphorus. Phosphorus is slightly more electropositive than nitrogen. Now why is it so? And nitrogen is smaller in size as compared to phosphorus. Due to its smaller size, the net electron charge increases, hence its nuclear exerts greater force on the electrons. That is the reason why nitrogen is more electronegative element than phosphorus. Okay, because whichever element accepts electron is electronegative, right? So where were we? Yeah. So the first line is clear to you. Phosphorus is slightly more electropositive than nitrogen. Means nitrogen is more electronegative because it accepts the electron. Its presence in polymer invariably produces the greatest flame retardant effects known. Hello? Hello? Yeah. So its presence in polymers invariably produces the greatest flame retardant effects known, probably due to the formation of phosphorus oxygen glasses at the surface of the burning material, and it is most often used for these effects. So what does this phosphorus oxygen glasses do? They do not let the polymeric material burn further. Therefore, it acts as a flame retardant. The P single bond O single bond C POC bond often provides useful structure for incorporation into polyethers, polyesters, and polyurethanes. The direct PC bond may sometimes be accompanied by very high toxicity and is not commonly used in production of polymers because we don't want polymer to be toxic.